Problem 22 asks us to find the probability of getting heads on a fair coin. Now we are writing a probability statement, but then we're going to also write its complement. So the probability statement would be probability of getting heads. The complement, the probability of not getting heads. And I've seen the complement statement written in different formats, but I'm going to go ahead and use this one for you. If you end up with a different teacher that does it in a different format down the line, you should be able to draw the similarities from the two different formats. Find the probability of getting tails or rolling a 6. The complement, probability of not getting tails or 6. Probability of getting a sum greater than 4 on a pair of dice. Complement, probability of not getting a sum greater than 4. And one of the reasons we look at probability statement and its complement is because we should be able to realize when we've calculated the two that the probability of getting a heads and the probability of not getting the heads add up to equal 1. Which, in other words, the two events together add up to 100%. Which is beneficial to us at times because sometimes, especially with some of these sums, it's quicker for us to find the probability of not getting a particular sum than it is for us to find the probability of getting a particular sum. And we did that in class when we talked about getting the probability of all of the sums greater than 2. Well, the probability of all of the sums greater than 2 we know are 35. But when we look at a sum chart, there is one value, which is 2, so we could find the probability of not getting greater than a 2, which would be 1 out of 36. Subtract that from 1, and that would give us 35 out of 36. So sometimes it can be a little bit quicker to find the values for the complement and subtract it from 1. 25 draws tree diagram to show the possible outcomes for 3 coin flips. Validate your solution using the counting principle. I'm going to go ahead and validate my solution. The counting principle. Well, on a coin flip, there's a sample space of 2. On the second flip, a sample space of 2. And on the third flip, a sample space of 2. 2 times 2 is 4, times 2 is 8. When I create my tree diagram, I should end up with 8 solutions. So my first outcome is heads or tails. My second outcome, heads or tails. My third flip, heads, tails. And so now I can create a list showing my possible outcomes. One would be heads, heads, and heads. Another would be heads, heads, tails. Third, heads, tails, heads. Fourth, heads, tails, tails. Oh, we need that. Fifth, tails, heads, heads. Sixth, tails, heads, tails. 7, tails, tails, heads. 8, tails, tails, tails. So we have in fact gotten 8 possible outcomes for flipping 3 fair coins.